Hi there, welcome. I have the pleasure of introducing Professor Manwell today. I'm Vicki May, a professor in the engineering school at the Thayer School of Engineering here at Dartmouth. I am not a wind expert, but I'm learning, okay? And I am having fun learning from Professor Manwell. Professor Friedland wanted me to make sure I mention it's part of the Leading Voices series. So for the next 3 Thursdays, there'll be speakers. Next Thursday at 4 is Janet Milne from Vermont Law School talking about carbon taxes. So there will be 3 more lectures in this series. Please join us. Today, Professor Manwell, he has given a lecture to the class earlier today, and I learned a lot. Professor Manwell is at the University of Massachusetts at Amherst right now. He has a bachelor's degree in physics from Amherst College, and that's in physics. Then he saw the light and got engineering degrees from the University of Massachusetts. He is a pioneer in wind energy. He, at lunch, told me that he built one of the first, or one of the largest wind turbines in the US. In the US, right? No? I'm misspeaking?
I can explain, but...
okay, he's going to explain about that. It was a good story, okay? He's also written one of the textbooks, one of the main textbooks on wind energy, which I have purchased a copy, and I'm partway through it. It's a large textbook. He's currently looking at offshore wind, and that is partially what he's going to talk about today. So welcome, and thank you.
Well, thank you very much. It's a pleasure to be here at Dartmouth, even though, as you heard, I went to a different college, Amherst College, which, of course, we always had to pay attention to Dartmouth as almost as good as us, right? But then I went to UMass, as you heard, and I've been dealing with wind energy pretty much ever since. So let me get started. Today, I'm actually not talking about offshore wind. That was in the class earlier. That's what I do mostly. But I'm going to talk about wind energy and the resistance to it, mostly in New England, but a little beyond as well. So it's a different topic than the class that I was at earlier. Give a little bit of background or a little outline of the talk, a little bit on the historical use of wind energy, the context for modern wind energy, and the rise of the resistance to it, and look at the health impacts, which is been suggested as one of the bad things of wind energy. And then a few words on how to respond to that, to the resistance that's arisen. Okay, I always like to start at the beginning. I'm never quite sure what the beginning of wind energy is. Obviously, for sailing, it goes back thousands and thousands of years to ancient Egypt. It was probably, the first windmill was probably in Greece, perhaps, maybe in China, but anyhow, there's a picture of a supposed Greek windmill from 330 BC. It was used for mechanical power for more than 1,000 years, in Europe in particular. It was probably the second major form of mechanical power until the Industrial Revolution, second only to hydropower. First electricity generated in 1888. Although that was supposed to be in Cleveland, but the Scots now claim that it was actually in Scotland. So if anybody here from Scotland, they could make me talk about that. And there's a lot's happened over the last 100 years in the production of electricity from the wind. This picture on the lower right is I guess it could be considered the grandfather of all modern wind turbines built in Denmark in the 1950s, but like everything, it had its precedents as well. So what happened to wind energy? It was so promising. Well, the industrial revolution basically supplanted it. Coal was obviously a lot more convenient than wind. Oil was convenient. You could just put it in your gas tank, whatnot. So the use of wind energy definitely dropped precipitously with the rise of fossil fuels. But as we've begun to learn over the last, whenever we started to learn it, in the late 1970s maybe, some people started learning it earlier, fossil fuels are certainly finite, they're difficult to extract. They're often found in inhospitable places, and they certainly release CO2. There's no doubt about that. They frequently lead us to war, and strip mining, obviously from coal, is quite a serious issue. In my previous lifetimes as a graduate student, I got to spend a lot of time in coal strip mining areas in the South. And if you want to hear and see environmental impact, you can certainly see it in those strip mining areas. I'm not going to talk too much about climate change or global warming, but I think it's important to note that we should all know by now that the CO2 in the atmosphere has been rising quite rapidly over the last 1,000 years or so. 1,000 years, look at the 1,000-year date, 1000 AD. That's when the Vikings discovered North America. And so they were just sailing here, of course, but then with the rise of the Industrial Revolution, all the coal burning created the CO2, or released the CO2, and brought us to where we are today. Now, and you're thinking about what's going to happen with or what can be done in the future. We always have to be aware that in the United States has a relatively low population. As you see, the pink bars indicate the population. And the per capita energy use is pretty high. And in other parts of the world, Africa, Asia, China, actually the relative populations, because it'll be much higher, and the energy use is per capita is pretty low. So this suggests that the energy use and release of CO2 is mostly going on by a relatively few number of people. And this is a situation that clearly is not sustainable in any way, shape, or form. If everybody ends up using the same amount of CO2 that we do, then there will be a real problem, even worse than there is. And if we keep using as much energy as we do per capita, then that will certainly be seen as unfair at best. So what do we think? What are the conventional energy options that we're thinking about, or that we use, or the alternatives? Well, fossil fuels, obviously, is the major source of CO2 and global warming. And we know that oil is limited and where it is. Who has it? Coal. Well, obviously a lot more coal. We have a lot of coal. China has a lot of coal. But it has a relatively large amount of CO2 released per kilowatt hour of heat content. Natural gas, of course, has less CO2 per kilowatt hour, but not that much less, or roughly half, I think, on a per unit of basis. If you burn natural gas in a combined cycle gas turbine, then your efficiencies are higher than coal combustion, so you do a little better than that in terms of CO2 per unit of CO2 per delivered unit of electricity, but it's still significant. So natural gas, going to natural gas is not going to stop CO2 production altogether. Then there's a question of fracking. I'm not going to discuss fracking in any detail, but obviously that's, as we all know, that's the way that natural gas has gotten a lot cheaper than it was before. A lot of people think fracking is just great. That's probably mostly people who aren't either profiting from the fracking or who live somewhere else. Nuclear power, again, I'm not going to say too much about nuclear power. I did just hear that James Hansen is now advocating it. I don't. I have to say I'm quite happy to say I have no interest in nuclear power. You need to look at, when you think of nuclear power, the actual supply of uranium, which turns out to be fairly limited as well in an inaccessible form. There is lots of uranium, but a lot of it's in the ocean and not that easy to extract. The waste disposal issue, if you just ask Harry Reid from Nevada how easy it is to store nuclear waste, it's not that easy. And of course, I could have had a picture here of the Fukushima nuclear power plant or Chernobyl. I don't, but nuclear has plenty of issues that would need to be resolved before it becomes used widely. So I think that, well, from my point of view, the reasonable approach is to move towards a completely renewable-based future, energy future. And this is not a crazy idea. There have been numerous reports in many countries that, that indicate that we can reasonably have a very high, at least very high fraction of our energy supply from renewables. Even in the United States, there's one talk about 80%. And I showed some figures that came out of Germany a few years ago as well. So it's certainly possible. It's not necessarily easy. It's not necessarily trivial. And it's not that there will be no problems. But fortunately, at least from my point of view, since I switched to engineering, it's ideal because somebody once says that people that engineers like problems, especially those that take more than a day to solve. So I think this is a great opportunity for engineers in the future. Anybody who thinks they want to be an engineer, that there's lots of issues. And then you hear there's a lot of naysayers who say, well, you can't do it. But of course, the engineer would say, well, that just makes it more interesting. So, but if you look at the options, if you look at what are the renewable energy options, there are really quite a few. But the primary ones are really solar, solar electric, and wind. And I could be giving talk on solar energy. Actually, I think that solar in the long run is going to contribute more than wind. And there are good reasons for that, kind of thermodynamic reasons almost. If you look at where does the wind come from, wind comes fundamentally from the sun. That the sun heats the earth, and it creates areas that are warmer and areas that are cooler, of course. And the warm air rises, and that eventually gives rise to the wind. So you'll obviously have less total available energy in the wind over the surface of the earth than you do sunlight. But it's certainly up until recently, at least, wind energy is already in a form that's easier to extract. And going forward, I think that no matter what, you'll see that wind and solar are the main options. Geothermal, biomass also have some potential. Biomass has its own issues that you have to consider as well. Geothermal is another possibility. It doesn't come from the sun, but it has some potential. And so how are we going to do this, actually? I mean, it's one thing to say, well, either we can do it, or we should do it, or we ought to do it. But how physically can you do it? How can the engineers actually do this? And one of the keys to all this is having what we call smart grids. And we have the electric grid that we know now so well. We have a lot of towers and lines and poles that, of course, some people think are ugly, but generally they've gotten used to them. But by no means are they considered smart in any sense of the word. That means you put electricity in at one end of the power lines, and you get that out in your iPod charger or your lights at the other end. So there's a lot of work going on now, again, all over the world, looking at ways to make the electrical grid smarter in many ways. And with these so-called smart grids, one of the keys to them is having electrical loads that are controllable and relatively intelligent. And what does that mean? We could go on to that some length. I won't say a lot, but they'll probably all have a little chip built in them so that when you plug in your washing machine of the future, the grid will recognize it and say, oh, this is a washing machine, and it'll help figure out what to do. Same with your water heater and things like that. So that'll make it possible to accommodate supplies of energy that are fluctuating, such as the wind. We all know that the wind doesn't blow all the time in a constant way, just like the sun doesn't shine all the time. So you have to be able to match your loads with your source to the degree possible. There'll also be system-wide energy storage. I think for a number of years, even people like me, renewable energy people would say, well, you don't really need storage. Well, of course, you don't need storage when there's a small amount of your grid with, from, say, wind or solar. But if it's going to be 50% or 80%, well, then you do need storage. And so there's a lot more interest all around the world now looking at different kinds of storage options. Fuel substitution is a kind of a storage option. Electric cars are one that's being looked at quite a bit these days. So you could, in this model, you charge your cars when the sun's shining or the wind's blowing, and then you use your cars other times, and when the car's not being used, if storage is needed, they could be integrated with that as well. Eventually, there'll need to be fuel production. That's not necessarily simple or cheap, but it's of course what we use now. We have fuel production from solar right now, right? That's oil. It just that it took a long time to make the fuel. But you can do this by making electricity from the wind or the sun and using that to electrolyze water to hydrogen, and you can use hydrogen directly or use it as in some other form. So certainly possible. So this is kind of my vision of the future, which would move towards, let's say for starters, 100% renewable energy. So how does, at least today, how do we get fuel savings and a CO2 reduction from the wind, which is certainly quite possible. Some people would even argue that, but normally the way the grid works is you have multiple electrical generators within a grid. You have what are called base load power plants and intermediate load and peaking plants, and depending on what the load is at any given time, different generators will be operating, and there's generally some forecasting involved by an independent system operator that will help decide which plants are operating. If you have wind or solar in the system, then these will reduce the need for other generation. If the amount is relatively small, then they'll simply reduce the fuel on one of the generators, the fuel consumption on one of the generators. If the supply of the wind or the solar is very large, then certain power plants will be shut off and others will be running. And of course, there's always need to pay attention to what happens if the wind stops blowing or the wind gets too high or there's a cloud. But these are the kind of issues that are fun, interesting to deal with and quite readily solvable. So fundamentally, that's what happens. We see down here some random curve from a typical fossil fuel plant. It's a coal plant. And what happens as your wind turbines or your solar plants are running is if you would be operating up here without the wind, then you'd be operating at a lower load. This is the power down here. And so as the load goes down, then the fuel consumption drops. So it's at small penetrations, that's the term that's commonly used. It's quite simple. At higher penetrations, it's more interesting. But certainly going to 50% is an amount you can go to kind of quite easily without major modifications typically to your networks. Okay, here's one view of the future that came out of a study in Germany from a few years ago. I just want to point out, well, of course, Germans love the sun, because there is no sun in Germany, right? If you've ever been to Germany. I've spent a fair amount of time, and I see that one of your professors here, your German professors from Dartmouth, he spent a lot of time in Berlin where he knows that there's never any sun. But so they're dying for the sun, the Germans, and I guess they want to get off from North Africa or something. But they have a lot of photovoltaics. But there's a lot, this is in 2100. Their view of the future is lots of sun. And maybe they just shift the Earth's axis and they get more sun. I don't know. But here's the wind right now. And so as you see here, they're imagining by 2050, kind of roughly 50-50 solar and wind are the new sources. There's biomass as it would be a contributor as well. So this is one view of the future. There are other views of the future that would have it kind of the other way around, more wind and more sun. I tend to think eventually there'll be more sun and more wind, and less wind, but certainly an option. So serious people have looked at these, and again, Germany is a very interesting case in point because they've decided basically unilaterally to make a major conversion of their energy supply, moving away from nuclear and to a very large fraction of renewables. So what's been happening over the last several years is there's been a dramatic rise in the use of wind energy throughout the world. Whoops. And here's a graph here. Wind's been going up like this. Geothermal just a little bit. Solar, which is interesting. Certainly the price of solar has gone down, and that's going up as well, but it's really not nearly as much. And biomass has moved up steadily. So wind, the point of this graph is to illustrate that wind is certainly going up at a pretty substantial rate all over the world. I have a few pictures of some wind turbines here. This is a typical modern wind turbine of a few years ago. It's not the biggest of modern wind turbines. This has a rotor diameter of a little over 150 feet, 47 meters. This is in Hull, Massachusetts. You can see it's so this is the high school right there, and so it's right at the edge of the football field. And the people in Hull actually liked their turbine so much they got another one. They got that was 1.8 megawatts. So some people like them. Turbines today are typically not installed individually. They certainly can be, or small numbers. They're often installed in relatively large groups. They're called wind farms. Most of the large wind farms in the United States are out west, relatively flat areas. But there are certainly some wind farms on the East Coast as well, and smaller ones in New England. You can't, being an engineer, I can't not have pictures and gears and whatnot. So this it just shows some of the components of a typical wind turbine. Obviously, the blades go way out here somewhere, but then what happens is the blades are attached to a hub, and the hub rotates, and then the hub then is connected to some shafts. The shaft, the whole rotor turns relatively slowly, but the power then goes into a gearbox. The output of the gearbox is relatively fast, typically. It's hooked to the generator. The generator makes electricity just like it would in any other kind of electric generating plant. And then there are cables and a whole variety of things. It's all mounted on a frame. There's a yaw system that enables the direction of the whole rotor to change as the wind direction changes. And there's a control system that tells it what to do. A tower that keeps it up in the air where the wind is, and a foundation that keeps it from falling over. So those are the main components. Now, getting into the next part of the talk really is what else has been happening. Turbines are getting bigger over the last several years. Now, this particular figure, it's not. This is the UMass wind turbine. This, when I was a graduate student, this was briefly the world's largest operating turbine. And it was only the world's largest operating because everything else that was larger was broken at the time, but that's all right. We were just graduate students, and we like to claim it. The turbine that I was involved in putting up was this one here. So it wasn't the world's largest. It was actually the largest in Massachusetts. But then I was also participated in this one, which was called Hull. We just saw this, Hull Wind 1. It's bigger. We didn't build it. A company called Vestas built it. And as I say, they liked it so much they put in a second turbine that's called Hull Wind 2, 1.8 megawatts. So that's the end of my practical experience with putting these things up. So I moved into the ocean. I liked being at Hull. Hull was right on the water, and I thought that was pretty good. So I just keep going. So these are some bigger turbines that are used for offshore. They give you some sense typically, although I think this Emden turbine in Germany is actually still onshore. So they're getting quite large. But I don't think anybody can deny whether you like them or don't like wind turbines. They're getting bigger. And there are a number of reasons for that. For one thing, there's more wind higher in the air. And if you want to get, it's windier, the wind speeds are higher. And if you want to capture the wind, then you go where the wind is. As the bank robber Willie Sutton said when they asked him, Willie, why do you rob banks? He said, that's where the money is. So in the case of wind turbines, you put the rotor up in the air where the wind is. Nobody ever heard that before? Yeah, okay, good. All right. So what's happening? There's a lot of wind turbines going up, and they're getting bigger. But there's also growing resistance to them. And there's a variety of reasons. I'll go over some of these reasons. I'm going to focus on some of them in more detail. But the factors I think that mostly drive the resistance are proximity to people. The resistance typically is greater where there's more people in the vicinity. They have a visual impact because they're big, and they can be heard. How close you are depends on how much you hear, but they can be heard. So that's one reason. They also are definitely a threat to the fossil fuel industry, and so there's some more going on behind the scenes than meets the eye. And there's politics. Some people like wind turbines and some people don't, and that often divides down the kind of the right-left, red-green, or something like that axis. So you can't separate these, and sometimes the objections and the resistance is kind of all mixed up, and it's hard to separate what's going on. So there's a number of people who are objecting to them, and these are just a few of them. One of the best known objectors is called the Alliance to Protect Nantucket Sound. That is a group that was set up to basically stop the Cape Wind project, this offshore project in Nantucket Sound. It's funded largely by the Koch brothers, if you know who they are. They live near there. They don't like to look at it, and they're getting most of the money from the fossil fuel industry. So that's a major piece of that. There's a woman, an MD named Nina Pierpont, who's written or has proposed something called wind turbine syndrome, which is a variety of symptoms that she says are due to wind turbines. And she's written a book about it. Not to let the Europeans off. There are people in Europe who don't like European wind turbines either. This is called the European Platform Against Wind Farms. And as you can see how threatening these black turbines are to the little German village or something. And there's this one here. This is the Industrial Wind Action Group. They're just one of the many websites that put out all kinds of information about why you shouldn't want wind turbines. Cape Wind is a whole story in and of itself. It's an unbelievable saga. I got somewhat involved in it even before it was Cape Wind. Naively, somebody asked me, what do you think, there's all these wind turbines in the US, in Europe rather, where do you think, could we put them anywhere in Massachusetts? And so a bunch of my graduate students and I kind of looked around and said, oh, look at this. Nice, it's good sandy soil, not too many waves, good wind. What about Nantucket Sound? Well, a few years later, a fellow named Jim Gordon thought that was a good idea, and the rest is history, or it's actually history is still going on. But there's a great story by a woman named Wendy Williams about the Cape Wind. I don't want to say too much more about it, but the words or the subtitles say it all. Money, celebrity, energy, class, politics. It's all there. So, and it's all right in the view of the Kennedys and the Koch brothers. So, see, what I put on this slide is some of the objections, not all the objections to wind turbines, and what I call the scale of plausibility. It seems that maybe Harry Potter could have come up with a term somehow like that, like the cloak of invisibility or something. And so there's more or less, I've ranked them from the most legitimate, as I say here, legitimate to understandable to just misinformed, perhaps well-intentioned, and disingenuous, which I think is a deliberate distortion. So starting at the top, so this list on the left is more or less aligned with the list on the right. So when I say turbines are too close, there's something called shadow flicker and excessive noise. And I'll talk a little bit about more of that. Then moving down, turbines are visible. Turbines are, there's no doubt about it, and they are audible, at least at some distances, and you can see them again. There's something called the NIMBY effect, which I did put in here. Some people say, I like these. Somebody actually said this to me. I couldn't even believe that he actually did at a meeting I was at. He says, I like wind turbines, just not in my backyard. He actually said it. I didn't think anybody ever said that, but they did. I testify. Then there's health effects. The wind turbine syndrome and infrasound and all these things that, well, we'll see. But there's certainly, people say that. Then there are spurious complaints. Turbines can break. Yeah, turbines can break. Airplanes can fall. The trains crashed in Spain yesterday. And then developers get rich. Sometimes people kind of on the left side get worried about wind turbines because they think developers are just getting rich somehow. And then there are just the totally implausible objections. Like some people say turbines just don't reduce CO2. They don't save any fuel. So I have to put those at the bottom of the list because at some point physics is invariably useful. Okay, so and then there's some, as I say, there's a lot of pieces to this puzzle, and that's part of the problem. Is sometimes it's hard to separate what's true or plausible from what's really not at all. And there's some suspicious things to consider. and which was this campaign against wind energy. I discovered after the fact, I'm going to talk about a panel that I was on in a minute, but there's been a number of campaigns over the last 20 years against things that other people might think are reasonable. For example, tobacco. So a lot of people have concluded some years ago that tobacco wasn't such a good thing, and then pretty soon some people sprung up and said, well, that's not so bad at all. And DDT is really pretty good, and maybe acid rain doesn't really matter, and global warming, I don't think it really exists. We need more scientific study. So there's a book about this called The Merchants of Doubt, and I only learned today that one of the authors was a professor here at Dartmouth some years ago. Anyhow, there's a whole kind of way of discussing these problems that sow doubt, and there's certain words that are used in there, and it turns out that some of the opponents to wind energy looks like they just read this book and used it as a training manual, even though the book is actually in the opposition. So then what's going on? There's more obviously going on behind the scenes, or maybe it's not obvious, but there's a lot going on behind the scenes, and it's often hard to separate what's what. But this article from The Guardian from during the election was talking about it's an expose of conservative think tanks attacking the Obama energy policy. Obviously, Obama's energy policy has a lot, is aligned with wind energy. We'd like to make more wind energy happen. And then there's another set of documents came out regarding the Koch-funded groups plotting to undermine climate science. Actually, I think it was Bill Koch, just an article just a month or so ago, talking about Cape Wind again, said that he was just going to keep spending money until they gave up on lawsuits. So he was pretty clear. I mean, he's quite honest. I actually kind of like it that I don't have to think too hard about. I don't have to say, well, maybe he's doing it. I mean, he says he's doing it. So I don't, nobody says, well, gee, he's not really doing it. Okay, so let's talk about, to focus on a couple of supposed health impacts. Because there was a lot of objection, and people were saying, oh, we're getting sick, and this is really bad news. These wind turbines, they're really killing me. I think one website even says that. But so the Mass Department of Environmental Protection convened a panel to review the literature on health impacts, look at some best practices, and then write a report. And quite honestly, I hadn't actually given a lot of thought to all the opposition up until then. I got asked to be on this panel as the wind guy. So they had a bunch of doctors and epidemiologists and people like that who were kind of they just didn't know anything about wind energy to start with, and I think they figured, the DEP figured they had to have somebody who knew something about wind turbines in there too. So so I was part of this panel, and we read all these papers and issued a report. And I thought it was a fairly objective, mild-mannered report. We all agreed on everything, which is kind of amazing. And but I have to say, the opposition did not. Some of the opposition did not like it, and so I found my name maligned all over the place. It's just really bad news, guys. So either I was the panel was either pro-wind and prejudiced, or ignorant. So I guess some of us were too pro-wind and some of us were too ignorant. Okay, but I'm going to just look at the three issues that out of all this literature that appeared as possibly real, or possibly significant health impacts. I mean, there's a lot of things you could address. We did look at this wind turbine syndrome, so-called, but and certainly in the peer-reviewed literature, there's no evidence that it's a real syndrome in any kind of conventional sense of the word. So I'm not going to discuss that anymore. But if there's ever a study that there is a wind turbine syndrome, then we'll be accepted, I guess. But the three that I'll talk about are ice throw, shadow flicker, and noise. So I think there's no doubt that if you have ice on a blade, or if you have ice on any structure, first of all, if you have ice on any structure, it can fall off. If you have ice on a wind turbine blade and it starts up, say after an event when the ice is on the blade, then it could fall off. So I think there's just No doubt about that. If you're underneath a chunk of ice that falls on your head, then that's not a good thing. So I think it's pretty clear that you don't want to be standing underneath a wind turbine which is covered with ice and then starts up. I've done it. I mean, I've been there. We had this wind turbine that I told that isn't the largest ever, but we used to do all kinds of great things with this turbine, and we started up when it had ice on it and watched what happened, and well, we'd get out of the way. But actually, the worst impact we saw was that this particular turbine, as it starts up, the blade goes like this, go round and round, ice comes off, and then if you're just unlucky, the blade hits the chunk of ice, and you ding the blade, and you have to fix the blade. So it does happen. Fortunately, here's where physics is real useful, and nobody can really even argue very much. It's pretty straightforward to calculate what ice is likely to do if it gets thrown off. It gets a little trickier when you take into account the ice it turns over as it flies through the air, and so the effective drag will slow it down, and it gets a little more interesting. But you can do this, and so it's a constrained problem in some ways. The ice can be carried by the wind. You always have to, the problem becomes more interesting then. And so you have to separate how much of the movement is due to the ice being thrown and how much due to the ice falling. But you can do it. So let's get down to the bottom line. There's been experiments and papers written. And so typically you can find that your roughly maximum distance is about 1.5 times the diameter of the rotor plus the tower height is going to be as likely as far as it's going to go. So we're talking 80-meter tower. That's good size tower, So we're talking 240 meters, a quarter of a kilometer. Okay, so and then in addition, of course, you can, if you want to implement control strategies, you can do that, and you can decrease that distance. But I mean, that's kind of all there is to the ice. I mean, yeah, it's a problem. Don't stand underneath the turbine with the ice falling off. Shadow flickers, a little more interesting problem, perhaps. Shadow flicker is due to the passage of the blades between you, if you're being subject to shadow flicker, and the sun. So if there's a sun over there, here comes a blade, I'm standing here, and right now I can see the light, and then the blade goes, and I can't. So you get this effect of a flicker that light, no light, no light, light, no light, back and forth, that is basically as frequent as the rotational speed, or the passage of the blade. So it's about once a second. Shadow flicker is actually totally determinable by physics. Where's the sun? Where's the observer? And it's pretty straightforward. You can get computer programs that will tell you when it is. Now, what makes it more interesting is it will vary depending on the season, the time of day, and things like that. So sometimes it will be flickering, and sometimes it won't be flickering. And there you go. That's the story there. This is a picture of what it looks like. People have done studies, though, as to where, and this drawing doesn't tell you too much, but you can plot the path of the flicker, essentially how far it will go, depending on the season of the year, the time of day, and whatnot. So that's part of this the deterministic aspect of the whole problem. What's somewhat less deterministic is how much it bothers you. And fortunately, there's been a lot of studies in Germany, in particular, about shadow flicker and occurrences and what bothers people and whatnot. Generally speaking, the higher latitudes you're at, the more the sun is low in the sky, certainly in certain seasons. Well, generally lower in the sky, and so the shadow flicker tends to go for a greater distance. So these tend to be more of a problem in higher latitudes. Basically, based on these studies, some recommended practices came out that the shadow flicker should be kept to below 30 minutes a day. For anybody who has to be in the presence of that, and And the also suggestion is that the total flickering time over the course of a year be limited to less than 30 hours per year. Not a huge amount, and of course it's going to be less. This assumes clear days. The actual fact, if it's cloudy, then of course it would be less often. This is something that can be determined before a turbine's ever put up. You can adjust your locations in accordance. Many manufacturers have control systems that will implement speed control of the rotor to reduce the effect of flicker, or in principle they could shut it down if you really had too much flicker. So it should not be a problem if kind of proper measures are taken before the turbines are put up. Now let's look at sound. Sound is probably the most real of all the issues. I think I have more slides than I have time for on sound, so I'll just try to highlight a few things. But sound is clearly an audible vibration. We're talking air in this case. They're vibrating and the pressure goes up and down. And depending on how fast the vibrations are, you have a different pitch. High frequency vibrations like a flute or something like that. There are a lot of up and downs in a given amount of time, and lower pitch sounds of drum, the frequency is lower. And of course, loudness is associated with amplitude, and that's what is, of course, a major concern. There's a wide range of frequency that the human ear can hear. There's something called infrasound, which is below 20 hertz. Some people have argued that infrasound has bad effects. There's not much evidence that that's really true, except under some limited set of conditions where the infrasound is essentially converted to an audible sound. But I won't talk about that too much either. So what are its characteristics? Amplitude, that's really how loud it is. The frequency content, that has to do with there's different, kind of like music, there's different musical notes, a different frequency associated with them. And there's a whole story in here, which I can't go over in too much detail. But there can be a particular characteristic of any given sound. Obviously, any sound you hear that you can recognize as a distinct sound has a distinctive kind of spectral or frequency characteristics. There are other characteristics having to do with how long something lasts, whether it repeats itself periodically, impulsive sounds that go kind of regularly, but maybe strongly at a certain, strongly and then not for a while, then strongly again. So I thought this being not a math class, but I'm an engineer, so I have to have some equations, right? I couldn't do that. People are always talking about log scales and decibels and whatnot, so this is a quick reminder what logarithms are all about. So basically they're useful when things vary over a very, very large range, earthquakes and acids and whatnot. And so here's your, if you wanted a log of 1, you get 0, and a log of 10, you get 1 and whatnot. So that's just a reminder. You can go back and look at this. So sound measurements. How do you measure sound? It's typically measured in decibels or decibels. It's one of these logarithmic scales. It has to do with the pressure of the sound relative to some reference pressure. And these are important because people who are talking about sound talk about these a lot. Bells, decibels, and pressure levels and power levels and whatnot. This is kind of illustrates what's typically seen as a kind of irrelevant when you're thinking about the noise from anything, including wind turbines. If you have a 1 decibel change in sound, you can't really tell. If it's 3, you can tell. If it's 5, it's definitely noticeable, and if it's 10, it's perceived as a doubling in sound. Now, the state of Massachusetts has rules currently regarding how much a new source of sound can increase above the ambient, and the measure is 10 decibels at the current time. And there's discussion going on right now whether that number should be changed for anything, including wind turbines, or wind turbines in particular. This scale gives an indication on the decibel scale of what this all means. And you see things like 100, over 140, this is painful. I can see here at 100, we're talking what, street traffic, or a little street traffic is shown about 90. Over here, that's shown in wind turbine. Quite honestly, this is at some distance. The sound at the turbine is higher. So this is at some presumably reasonable distance from a turbine, and maybe even a little higher than reasonable. But these just give you a sense that this decibel scale is a way of kind of compressing a very, very wide range of sound into a much shorter range. There's something called the sound weighting levels, which are sometimes a contentious matter. There's something called the A weighting in particular, which takes into account how humans actually perceive sound. And humans don't perceive low-frequency sound very well, and this A weighting scale takes that into account. But many things produce a lot of energy at lower frequencies, and you would see that in a non-A weighted scale, but you wouldn't see it in the weighted scale, and that's a source of discussion. What's noise? It's unwanted sound, and I talked enough about the different considerations from before, so I don't have to repeat that. There is something called amplitude modulation, which is a term that's been introduced relatively recently into discussion of wind turbines, which has to do with how the sound goes up and down with the passage of the blades through a region of varying wind speed. The sound in a wind turbine could come from a variety of sources, and as this shows here, but the bottom line, most of it comes from the blades, from the aerodynamics. The total of a modern wind turbine is about 103 decibels on this A scale. This particular turbine is shown as a little less. This is a few years old, but that's a typical number. Bigger turbines are louder. In terms of aerodynamic noise, roughly the noise goes as the fifth power of the tip speed. So the tip speed goes up a little bit, the noise can go up a lot, and typically rotor sizes are there'll be higher noise. So generally speaking, larger turbines will be more noisy than smaller turbines, if no other changes are made. So that's one of the sources of people's unease with turbines. Sound propagation. Another whole topic in of itself, but sound will reduce with a distance from the source. So that means if you get a certain distance away, you can't hear much. And that's one of the questions is how far, what's the number? How far away should turbines be so that the sound doesn't bother anybody if you're bothered by sound? And let me just go on from here, give you an idea of a typical turbine, typical sound levels, and what you get at different distances. So this says 600 meters, roughly 600 yards from the turbine. The average sound pressure should be around 35, which is considered relatively low, and not too much above the ambient. There is a question of how loud is the ambient. So without a turbine, how loud is it? So at a quiet night, if it's 20 decibels and you hear the turbine at 35, well, then that might be too loud. So there's a lot to consider in these issues here. If you have multiple turbines, the issue is more complicated. The relevant thing is, in this particular case, on a line, we're talking about a line perpendicular to the line of turbines from 7 turbines. It takes you at over 1,000 meters to get to that same level. So more turbines are louder. You want to have the more turbines farther away if the sound is an issue. Annoyance, there's all kinds of things that are sources of annoyance. And it's much more complicated than simply the absolute noise level. A lot has to do with many things. For example, if you think that somebody has come into your town, wrecked your view, and is making money, and you can hear their turbine, you often get annoyed. If it's your turbine, and every time you see it turning and it's making you money, you think, wow, that's the sound of money. So, there are these issues to consider and how much you, and your attitude towards it. And there have been a lot of studies, most of them in Europe, but not all of them, that look at the relationship between sound and annoyance and attitudes and whatnot. One thing that did come out of this panel that I was on is pretty clear that if you have excessive noise, and if the noise is so high that you can't sleep, this is not good for your health. So I think in any situation where the sound due to whatever reason, is such that people can't sleep, then that's an issue that has to be considered. And turbines should, people, some there should be compensation. Turbines shouldn't be put there or whatever. So there are these real situations. So based on our, this again from the panel, based on a look at some best practices mostly in Europe, there were some recommended noise levels or maximum noise levels. These are a combination of Germany and Denmark for ranging from industrial areas through commercial down to residential areas, and that's at the moment kind of the best current advice, and people are still studying it. So the issue is if turbines are too close. So we're talking distances. In my experience, when people don't have some other reason that they don't like the turbines, that the objections begin to appear at a distance of about 1 kilometer from the turbines. And again, this factors on a lot of things. The turbines in Hull, the smaller turbine is considerably closer than 1 kilometer to residences. Not a lot of objection. But I think it's a safe bet that if your turbine is well over 1 kilometer and there's only one turbine, then not too many people are going to object to the noise. Somebody might. But as you get closer and closer beyond less than 1 kilometer, then the objections will start to increase. As a result of all this, what are the conclusions here? We've seen the nature of the resistance is multifaceted. Sometimes there are real issues. People have problems. And sometimes they're made-up issues. People don't want to sell less coal. So they vary. The objections vary and the resistance varies. So there's a number of things you can do. Obviously, being an educator, I think education is a big deal. And you have to be able to, there has to be more education over what are the advantages. Clearly, wind has advantages over other sources, and any source of energy has its own disadvantages. And so there's a question of balance. What advantages do we just only want to rip apart somebody else's coal mountain with coal, as long as so we don't have to have wind turbines or something? So there are issues to think about. Obviously, some impacts are real. It's no doubt that the benefits that we've talked about from wind energy use are global, right? If they reduce CO2 or if they reduce the need for oil or whatever, that's the benefits for the whole world. But if you're looking at it and you don't like it, then the impacts are local. It's clear, again, whether you're for or against, that the distance, the turbine size, and the number of the turbines matters, I think. And reasonable policies should consider local impacts, and there's a number of ways you can do that. At the same time, I think it's objectively true, as in the Merchants of Doubt, that the impacts are often exaggerated. But if if there are objections, they should be supported by evidence, and the evidence should be such that anybody could get it. It's just like you do an experiment. If somebody gets a dengue fever, I got dengue fever once. There's been a lot of experiments. People know what causes it. Right? It wasn't just one guy said, "Oh, that mosquito's bad." So I think that evidence is the secret. And so the last slide for policy suggestions, we have no renewable energy, national energy policy emphasizing renewables. If we did, I think that would be a big help. Public education, which is just what I was saying before. Typically, if you have local participation, ownership in projects like municipal electric co-ops, companies or cooperatives. Hull, for example, had a municipal electric company. That helps people to think that's my turbine. It's not their turbine. Financing incentives, there's multiple ways. I have no time to discuss this, but you can definitely develop your incentives in such a way that encourages turbines to be sited in areas that cause the least impact. And there is a lot of experience. There's a lot of experience in Europe already, Germany, Denmark in particular, that provides a great starting point for developing any policies that we have too. So I think that's all I have to say. I can take any questions for which there's time.
Hi.
Yes.
Hi. Dr. Manwell. I'm Virginia Irvine. I'm from Windwise, Massachusetts.
Right, I recognize you.
Windwise, Massachusetts has brought forth a bill that would actually consider objective medical evidence for the communities in Massachusetts. There are over 30 wind projects in Massachusetts that are creating health impacts for people right now. And we put forth a bill that would have epidemiological studies, which is one thing. I know that your study was a literature review, but this would actually be actual medical people doing medical tests of the people that are being impacted, and also epidemiological studies. And I just wanted to know if you realize that our governor has supported this bill, and he will sign it if it comes out of committee. At the hearing, the Sierra Club of Massachusetts, the legislative director, said she believes that there is wind turbine syndrome and that it will be proved in the future. It has been written up in literature review by Dr. Farbo of the UK, in the Journal of Otology and Laryngology. They are also saying that there is evidence and that we need the research. So my question to you is, will you come out and support this actual bill to do actual epidemiological and medical studies in Massachusetts?
I would have to read the bill before I would say whether I would support it. But of course, I always approve of more research.
I'll send it to you. Thank you.
Yeah.
I hope I don't sound harsh here, but you did say education is a big deal. Now, I have noticed some bias here, and the number one bias I've noticed is that you listed that the campaign against wind is like being for DDT and tobacco. I take objection to that. These all start off with people not being worried. DDT, people were not worried. Tobacco, people were not worried. Post-traumatic stress disorder should be brought in here. People were not worried. Wind, people were not worried. Another thing is, you use the decibel scale compared to the thermometer scale. Any engineer knows there is zero comparison between the thermometer scale that you put up on that slide and a decibel scale.
Excuse me?
You look at your thermometer
Just a scale, it's just an illustration.
And it's 10 times for every 10 on a decibel scale. Your decibel scale will be stretched out like crazy between your lines. On a thermometer scale, they aren't. Each one of them is equal.
Have you ever seen log scales on the graph?
You also didn't bring out the Kennedys on Cape Wind. You mentioned the Koch brothers.
I did mention the Kennedys.
It's okay. My years are not always the greatest. But, you know, there were several other things. I'd like to have a little more level, even keel.
Yes, I'm Annette Smith, I'm Executive Director of Vermonters for a Clean Environment. And we've seen 3 large wind projects built in Vermont in the last couple of years, and there's also one in northern Massachusetts. My life has become consumed with dealing with the noise complaints and the health complaints. And every day I wake up with more complaints about the noise and health effects. Ringing in the ears, headaches, dizziness, nausea, dry heaves, to the point of throwing up. We have one family with 2 small children, ages 1 and 3, who are desperate to leave their home. They don't have the financial resources. We've seen 21 3-megawatt wind turbines put up on a ridge line. They're too close together. I don't think you mentioned turbine spacing, but they're anywhere from 720 feet to 970 feet apart for turbines that are 459 feet tall. And the noise is going out more than 3 miles. This is a very serious problem for New England. I've lived off-grid with solar for more than 27 years. I support renewable energy. But I think we also have to learn from the experiences that we're having throughout New England, because this is happening all over the place, and it is devastating people's lives. When you have people who are desperate to abandon their homes, there's something really wrong. We've already seen a couple of homes put on the market. We've seen people who say, there's one in Massachusetts who's abandoned his home. He's going to turn it into an inn so people can go and stay there and experience it. But I was disturbed by your presentation that dismisses this when there is so much going on. This week in Vermont, we've already seen 3 news stories, Monday, Wednesday, and yesterday. There's going to be another one probably tomorrow. It's all about the health effects. And a lot of these people were not opposed to wind energy. They were in support of the project. So I hope that you will update your information. I mean, as you point out, the turbines are getting much bigger. We are likely to see turbines 500 feet tall. It is my opinion, after working on this issue for 4 years, that this is simply a technology that is not appropriate for New England, and it's certainly not appropriate to put anywhere close to where people live. And when you try and put it in remote areas, then those are the areas that the wildlife need for adapting to climate change. We also are seeing in New England a disrespect for our water resources, because where these are being put are on the tops of our mountains where the headwater streams are, and we need to protect this water to adapt to climate change. And my final comment is that you put at the bottom of the list the ability of wind turbines to address CO2 emissions. And while you say that they do, you haven't provided us with any evidence. And I do not want to be branded as a climate change denier. This morning on a site tour of Vermont Law School students, a wind developer accused my organization of taking money from the oil and gas industry. And we have never taken any money from the oil and gas industry. We are simply trying to help our citizens live productively. And I went to the most efficient natural gas plant in the New England system. It's in Londonderry, New Hampshire. It's a 750 megawatt plant. It's 70% efficient. I asked the CEO of the plant, he's got the ramping plan. When your plant ramps down to let the wind in, are you saving fuel? He said, my plant runs less efficiently when it runs down. I said, well, are there any flex generators in the grid? He said, no. So until we have flex generators, we are seeing a lot of curtailment in the system. The turbines that have been built aren't getting into, the wind's not getting into the system. And as far as I can tell, when you actually look at how the grid works, I've been looking for 4 years for evidence. Now, people talk about coal, they talk about oil. Natural gas in the New England grid has really almost, some people say almost eliminated it. It hasn't. I've been watching the grid, and there's been oil and gas during this heat wave, when wind projects have been curtailed. So I think that when you want to talk about education, we really need to have a much higher level of understanding of actually what is happening within the New England grid, and stop deflecting and saying it's oil and coal when we've already eliminated most of that. It's natural gas that we're talking about. And so I think that I would like to see more evidence, solid evidence, not modeling, but real evidence that these are making the difference that we're claiming.
Well, you're certainly entitled to your opinion. There was a master's thesis that came out of MIT a couple of years ago regarding energy saving or fuel savings due to wind energy, but it was based on the actual breakdown and makeup of plants in the New England grid, and the model. It was model based, but it was based on the New England grid, and looked at the savings, the CO2 reductions due to prospective wind farms.
Yeah, so. I mean, I've seen some studies, but I guess the question I'd like to ask you is, because we've already seen a lot of big turbines built that are genuinely harming people, what do you think that our government's response should be to that? Because right now we're just in the denial phase. It's not happening. So it's like the hot potato. Nobody wants to touch it. What do we do for people who can't live in their homes anymore, who are so sick, who are getting headaches every day, ringing in ears, saying, what's happened to my life? How can anybody do this to me? What do you think we should do for those people?
Well, as you know, the DEP of Massachusetts did set up this panel. We did look at all the information that was available. People were free to present whatever information they wanted. There is very little peer-reviewed literature. There's a lot of anecdotal literature, but very little peer-reviewed literature that suggests that any of what you're saying is true. If this becomes evidence, then that should be taken into account. But there has been a tremendous movement and creation of the so-called gray literature, internet literature that has really no basis.
I'm talking about real people who I know, who I've met, these are human beings. This is not a literature search. These are real people who are being harmed. What should society's response be to help a situation that's been inflicted on them? In many cases, it's their entire investment. They have no money, and they are being really tortured by this technology. Awakened at night, I've heard many people who talk about panic attacks in the middle of the night, their heart's racing. I know people who've been sent to the hospital, to the emergency room, because their hearts are racing because of the wind turbines. And you know, everybody seems to want to have proof before we'll address it. I think we need to have some sort of a response, because you're talking about peer review. Real science is based on reproducibility. We have seen this reproduced over and over and over again. It's the same symptoms all over the world. And to simply deny it, which is what you seem to be saying, because there's no piece of paper, these are real people. What do you think we should do for them?
Real science is not based on self-reported information either.
There's plenty of documents. Where is it? I'd be happy to refer you to it. You might talk about the
Sure, we can take that.
What's being done in terms of both policy and engineering to try to reduce the dependence of this technology on rare earths that we can only get from China and other hostile countries?
Well, rare earths are only used in permanent magnet generators, typically. So not all turbines by any means have permanent magnet generators. So you don't have to have permanent magnet generators. You don't have to have rare earths. So there are alternatives already, which is not to say that it's not worth coming up with other ways to look at creating permanent magnets. But typically those now use rare earths. So it's a good topic, but it's not a showstopper.
Yes. My name is Jim Bray, and I live in Pennsylvania, but we own a house in Vermont. And there's a couple of things that I would just like to mention. Firstly, I don't think there's any silver bullet as far as our energy crisis is concerned, but there's a lot of silver BBs, and I think wind can be one of those BBs. That being said, there's a couple of caveats. Number one, visual pollution is as real to me as a dirty stream in my backyard. It impacts the quality of my life. People don't realize these wind turbines are 400 foot high, they have a 12-foot wide base, and the blades are 120 feet long. In addition, in order to place these, they're placed up high, and the impact on the infrastructure can be really, really damaging with streams, forest removal, et cetera, et cetera, et cetera. My concern is the placement of these and the size of them. Just because we can build a 400 or 500 foot wind turbine, that doesn't mean we have to. The state of Vermont, its main industry is tourism. Tourists don't want to spend money to come into a state, the Green Mountain State, and look at wind turbines in every single mountain. So, a couple of caveats. I think the placement of these wind turbines has to be very, very carefully thought out. And the impact on the infrastructure has to be given careful consideration. But again, when those are done and the health, the health issues are addressed, then I personally don't have any objections to them. But those are really, really serious caveats, and you just can't go placing these things wherever people want them to be.
Maybe we have time for, I'm sorry, a lot of hands up. Maybe 2 more questions. I'll let you.
Sure.
Maybe I'm going to speak for a few engineers in the audience because there are questions that have to be addressed from an engineering point of view. Number one, wind is an intermittent energy source. Doesn't run 24/7. Electricity has to be available 24/7. So it has to be supplemented by conventional, stable sources. I won't even get into the grid issues because they're far more complicated than we could take on here. The second is wind is a very low density energy source. It requires a lot of land to be taken. You can only get so many watts per square meter from solar power source. How do you address that? And the third is from engineering experience, and that is they do not last or have the durability that were claimed. Maybe they're getting better, but there have been problems with the clutches, with the drives, with blades coming off, with icing that creates imbalance of the blade, any number of factors, plus the fact you have to have access to service them. So how do you address some of these real, true-to-life engineering issues?
Okay, well, I don't think we address them all, but there are certainly examples of turbines that have been in operation for more than 20 years. So you can certainly operate them. You're talking gearboxes, not clutches. Obviously, gearboxes are an issue that people have been looking at for a long time. Gearboxes are getting better, so that's what engineers do, right? They make things, you know, over time, they make things better. What you're referring to is how often do turbines have to be repaired, or how often are they broken. The turbines, I think, that went up in the California wind farms in the 1970s, 80s had availabilities, means they could operate in the range of 20, 30, 40, 50%, very, very low numbers. Most turbines today have availabilities in the range of 97, 98%. So a turbine design today is likely to last its design lifetime, I would say. Regarding savings of fuel, there are many examples already from a number of years ago from smaller grids, which are probably easier to quantify, supplied, say, by diesel generators, where wind turbines could supply up to 50% of the energy of the grids. And so this is not that hard a problem to deal with. It's different in a larger grid than a smaller grid, but it's certainly doable, and there's examples.
One last question.
Sure.
You mentioned California a minute ago, and California seems, from what I can tell, to be a place with a very advanced wind generation. As you said, they've had wind turbines for 30 years or so. The impact on the grid in California, at least according to the LA Times, the Wall Street Journal, and various other publications, has not been positive. It has been very difficult to manage that energy, and very expensive to manage that energy. So the state of California, in leading with the energy policy they have, which is certainly laudable in terms of wanting more renewables, the real world impact of that has not been what the state anticipated, as chronicled. And the LA Times, of course, is a historically somewhat progressive paper. So when you read it in a source like that, saying, hey, these proliferation of wind in the state has resulted in instability for the grid, higher costs for consumers, curtailment, a lot of issues that weren't anticipated when the wind was originally thought about, 20, 30 years ago, and has continued to represent a higher source of the state's power. I just think that those issues are real world issues. They have economic consequences, they have environmental consequences, and I think it's a real world example of be careful about the path you go down unless it's very well planned, very well thought out, and carefully considered.
Well, you certainly have to do your homework. There's no doubt about that. But there are plenty of examples where wind contributes a large fraction of the electricity of the grid, including Denmark. So, I mean, again, these are these are problems that are solvable, and people have solved them at grids at different sizes. So, but there's no reason that you can't. Again, I mean, you have to do your homework, but there's no reason that you can't can
I'm
do it.
really
I think
sorry,
we'll-
it's 20 after 5, and so I'm going to cut it off here, but come on up if you want to talk to Professor Manwell. Thank you.